So hi everyone, excited to be here for our webinar. And the overall goal of this webinar is to give you a little bit of information about how we think bioprocess data should be structured, alongside a little bit of pointers on how to and best practices for data collection, and a little bit on our platform. But first of all, a little bit about me. So I'm Yaron. I'm the CTO and co-founder of BioRaptor, and for the last 4 years, we're helping bioprocess teams get the most out of their data through visualizations and also machine learning and AI. In my past, I was a software engineer turned to a physician, and also have a PhD in neuroscience and several startups under my belt. And Bioprocessing, as I said, we're live for the last 4 years, helping quite a lot of customers by now to really make the most out of their data and accelerate product development. And more about that in a bit. So what are we going to cover today? And a little bit about how knowledge is being built, a little bit about data analysis and data analysis in bioprocessing in particular, moving from analyzing one run at a time to looking at processes holistically, talking about how to future-proof your data collection, and as I said, a little bit about the Bioreactor platform. But the overall goal for us, and I think for us as Bioreactor as a company, is to kind of convince you that your data contains gold. And from our experience, we're seeing that some customers, some people are not using all of their data and can do more with it. And kind of my goal for you is to know that there is more in your data than you're currently using. And that's the key takeaway for me from this webinar. So a little bit about how you build knowledge and understanding. So we all start in bioprocess, we all start with biological systems. And so that could be the upstream, the downstream, where we have a biological system working and we are measuring things. So these things that we are measuring can be online. So these can be the flow control in the bioreactors. This can be the pH. This can be the other online sensors that we have, like Raman or conductivity OD600. And these things turn into data. And this data is something that we use to generate information. And this information later on turns into knowledge, allowing us to understand our process better and optimize our process or make it more robust, whatever our goal actually is. And we see sometimes teams get stuck between the layers, and you really have to make sure that all of the layers are working coherently so that you get your knowledge right. And this is practically what we do at BioRaptor. We are a full stack company from gathering the data to generating knowledge. So in order to just discuss how we do this and best practices, I'll just discuss a made-up company called ENG Bio. And ENG Bio is producing muscarinic acid by using precision fermentation. And currently, this is sold for $200 per gram. And ENG Bio would like to drive the cost down. So in our world, how do we try to drive the cost down? Well, we try different things and try to see what works. And how do we understand what works and what doesn't? Of course, we run experiments. This is what we know how to do and how to test and validate our hypothesis. So these experiments work in different ways. One way to run an experiment is just ask, let's see what happens when I add more of one of a media element. So let's say that I have an hypothesis that if I add more glucose to the process, my COGS will go down. So, well, I just run an experiment and maybe I have controls the data, or maybe I don't have control data running alongside. But basically, I run the experiment. Let's say I have a fermentation process and I'm running this experiment and I am capturing data from offline parameters and from process parameters. And usually, to create a holistic view of it, I create a combined sheet of all of them, and then I go on and try to analyze the result of my fermentation. So how does this usually look like? I have a fermentation run, and these are my measurements. You can see this fermentation run went on for 48 minutes, and I have my online data. In this case, this is agitation. And you can see the graph here that I plotted not very nicely or not very nicely in Excel. And I have some process parameters, and I have my target, the concentration of my enzyme, which you can see that is building in the bioreactor over time. And I'm capturing other things like the temperature in my bioreactor, the pH and the DO. And now I can see that I created 5.7 grams per liter of my target. So that's pretty easy. I don't think anyone needs anything more than an Excel sheet in order to analyze one experiment. But what happens when I want to start to gain a better understanding of my process? Then I usually start asking more elaborate questions, like what happens when I change different things in my feed? What happens when I change different media elements? What happens when I change different process parameters, like the aeration of my process? And maybe I'm even interested in understanding the interactions of these. Then maybe I'm also doing a DOE in order to better understand those relationships. Then I end up doing several runs, and now I have different runs to compare. And now I have those endpoints, and I also have the process parameters. And then what people usually do is they create an aggregative Excel. So first of all, they create one Excel per batch, and then aggregate the results in order to compare them. So now I have my aggregative Excel here. And here you can see I have the time element here, the runs, the run ID, and temperature across the runs. And here you can see that I've changed different parameters between the runs, but I'm again capturing my target concentration. So how do I compare them? Again, let's create the graphs for the different target concentrations. And you can see it seems like these three runs are behaving quite similarly. I'm creating my target and I'm analyzing it, and it seems to be behaving quite nicely. Maybe I also want to align the online measurements in order to make sure that everything is working correctly, that I have no deviation, no pH excursions, no problems in my control. But again, I'll be probably creating a few aggregative Excels. It will take me a few minutes, and I can compare those different runs. So, but again, let's review this aggregative Excel here and start taking a look at it and maybe try to understand why it's important. So I can tell you that there is some hidden insight in this Excel. And if you would like to take a look, I'll stop talking for a minute or so and let you have a good look at this Excel. And feel free to write in the chat if you can see a hidden insight. Oh, I forgot to say, there is a prize to the first one who will unveil the hidden truth. Feel free to write in the chat.
Bob, you can tell us if you unmute yourself. Can you hear me?
Yep. Do you see any clues, Bob?
Yeah, I think with the increase of the airflow, probably we can get a higher concentration.
Yeah, so yeah, you're getting close. So
Yeah,
yeah, there's a difference in the airflow, but there's also a difference in agitation.
yeah, yeah,
And if you look closely, you can see that the target concentration reached 6.4 here, while agitation actually remained lower.
yeah,
And this gives us a clue that there is something else going on in here. And there is a correlation between agitation and probably maybe an inverse correlation between target concentration and airflow, which shows you that you really need to look at all of the parameters in order to optimize your process. And here, thanks, Bob, for participating and noticing. By the way, sorry, I get the prize because I noticed this first when I made the presentation. But so this is one example to show you how some insights can be hidden in sensors, in flow control, and these needs to also be accounted for. So now what happens now, because I'm sure many of you have more runs than just 3. So I won't do the same exercise, but just think what happens when you have 10 runs, what happens when you have 20 runs in your runs database, and try to think if you're getting everything out of your data. And we believe that this is a good time to employ better tools than the human eye in order to gain a better understanding of it. And that's why we've built Bioraptor. So this is just a quick slide to show you how it looks like in the platform, how outlier detection can work easily when the data is all in one place. But really, biology and our processes are far too complex to leave it to one factor at a time. We really think that, and from many of our customers, we see how looking at things holistically and thinking a little bit outside the box can give you a much better yield and better processes. And maybe now is a good segue to talk about AI, because everyone is talking about AI, but AI and machine learning are only as good as the data you feed it. And as the old adage goes, garbage in, garbage out. So how do you progress to having an AI-ready data? So I'm not talking about our platform. These are going to be just general rules on how we see from our experience that things should behave in order to progress in the fastest way to AI. So the first thing that you have to have is a singular data repository. If the data is all over the place, if some of the data resides on the bioreactor computer, if some of it resides on some experimenter's USB, some of it is on the HPLC computer, some of it is in SharePoint, then it's all one big mess and you can't get to proper machine learning like that. So first of all, having the data in one place. And once you have the data needs to be as structured as can be. So here is an example, kind of made up, but not really, from a process that we've seen. Of course, all of the names and parameters have been changed, but this is a progression of batch record that we've seen with a customer where you start very simply with just having the data from the bioreactor, but then things start to become more complex because now you know that you're inducing your process at a different temperature. You understand that you're changing the media parameters, so you add them. And maybe you've even changed your bioreactor. So things start to progress and change along the way. And you can see how the batch record from May 2021 is very different than the batch record from May 2025. And here as well, you can spot several differences between those batch records. And I highlight them. So first of all, changes in column names is something that will be detrimental later on. For the human eye, it's easy to catch. Later, when you'll try to make this machine readable and try to utilize AI, these are the things that are going to be very detrimental. Units. You can see that different units are used here for the airflow, so liters per minute versus liters per hour. And these are the exact things that are going to mean bad results and bad models versus very good models. So your data has to be easy to compare, and you need to be able to align it between equipment manufacturers and scales. So try to stick to a singular unit, the SI units, and even if the bioreactor manufacturer hasn't done it, convert it to the SI unit yourself. One huge thing that we're seeing is the lack of context, the lack of structuring in the batch record metadata. So here you see again the example from metadata. So this would be the run name. Maybe this is the organism. Maybe the organism name is not even written here. And here you can see this little story that is very easy to read as a human. But later on, when you want to ask a question like what is the best induction temperature, this will not serve you well later on. So we will show the Excel that we suggest to use, but really try to minimize the amount of storytelling in your Excels. Try to separate it into as many fields as you can so that it's more machine readable. These kind of stories really also are detrimental for the collaborative memory, the corporate memory that you're actually trying to create. And this is something that we see from our customers again and again, this story that comes up about someone repeating an experiment and then the director realizing that this experiment had been probably run before because no one was able to actually see because the data was just hidden in some file on a SharePoint and wasn't easily accessible. So again, minimize the amount of these little stories that you see here. And again, AI is 90% good data and just 10% magic. So really make sure that your data is good and then the magic will happen. So maybe I haven't said it enough times, but experimental context is very, very important. So we have customers who are using Historian as an example, and they have a very nice repository for all the bioreactor data, but when it lacks the context, when it lacks the why you're trying to do what you've done, the what you're trying to do, and these parameters just become meaningless. Then you can't do anything with just a stream of PO2 measurements or just a stream of pH measurement, no matter how big it is. So again, metadata plus data equals information. Without the metadata, your data can very easily become meaningless. One thing that we're seeing is that people don't properly add the strain or the cell type or are very inconsistent with it, and try to be as consistent as possible. Don't invent naming convention, but really employ one for everyone in the company. Vessel volume is important. It's very important as a metadata for my run to understand if this was done in a 2-liter canister or if this was a 250-liter vessel. The operation type, so the batch type was this a batch record? Was this a batch or this fed batch or a perfusion run? Maybe in the beginning you didn't even know that you should capture this, but soon enough you will probably be using fed batch, so capture that. Your experiment set points. So it's important to understand if when I'm seeing that the pH is 35, was this what I intended, or is this just an O2 excursion and something is out of bound? So it's important to understand if the set point was 35. So please capture that. Media does not matter if you use chemically defined media or you are using something off the shelf or you're constructing your own media. Capture this information. It's very important, of course, when you're doing perfusion and fed batch, but also for batch, capture this. The best is to also capture lot numbers. You'd be amazed how many times those different suppliers will be what makes or breaks your process, but it happens a lot of the times and harder to catch if you don't capture this information. And last but not least is what happened before and after your process. So let's say that you have a main bioreactor run, and sometimes you're using intensified processes, then capture what happened in your N-1 and N-2, maybe even your thaw vial, and then capture what happens after. Again, collaborative memory and also understanding processes holistically is very, very important. And so if we look at a singular batch record, this is how we think it should look like. It starts with the context, and this is the run level parameter or parameters or batch parameters. This will be available for you. Just if you want this template, feel free to email me after this session. I'll be happy to reply with our template. So you don't have to strain your eyes if this is not clear, but these are the run level parameters. So here, capture the run ID, when did it happen, the set points, the vessel, the media, and also the end of run results. So those things that you currently believe you are going to be asking questions later on, capture these. While this upper part is the batch record. So here you can see I have a run which lasted for 3 days, and I'm capturing the sensory data, or at least the points in time where I'm capturing this sensory data, some data about cells from offline measurements, and calculated expressions as well. So a little bit about how this works on the bioreactor platform. So we discussed at the beginning, seeing both the offline measurements and the online measurements. So here you can see how the platform organizes the data. So this is data, this is viable cell density in this case, coming from an offline measurement, displayed alongside something that's coming from the bioreactor, for in this case, the pH. And the system ingests data from both the offline measuring device and the online measuring device, in this case, the upstream bioreactor, and contextualize it and allows you to superimpose these types of data together to gain a better understanding of your process. This is how a batch record would look like. So this is a little bit similar to the Excel that I've shown before. So in this case, this is a process that lasted 300 plus hours. And this is the VCD, the glucose, all of the parameters are captured here. And users usually type them in as the batch progresses all the time. And this allows them to monitor the process again, seeing the online measurements alongside the offline measurements. And if we're talking about seeing the batch holistically, so if this is my main bioreactor run, you can see here, this is another batch that's connected to it, which is the N-1, N-2, and the thaw vial. So you can go back all the way to the cell bank and understand all of the conditions which your cells have endured to understand what is affecting your run. And this leads to the ability to also understand the difference of, in this case, pH. So if you've gathered this metadata for the runs, you can easily create these graphs and automate reporting out of your data. And here in this case, see growth curves and production curves for your organism in different pHs. So takeaways. So first of all, the key takeaway, take away the template. As I said, just write me, I'll reply with the template. Data capture, start as early as you can. The benefits are going to be immediate. Just think about how much runway repeating a batch costs your company. The ROI for capturing the data is immediate. Also, note the cost of not learning enough from your experiments. Just think about it. It's not the cost of the run, it's the cost of the run rate and the time it takes to bring your product to the market. And we all know that patients need your product, or other industries, whatever you're working with, we need it. You're creating the future. Please try to do it as fast as you can. And make sure that you have answers for who, when, where, how, and why when thinking about your batch records. So always know who did what, when was each and every step taken, where it happened, how it happened. So all the details about how the data was captured, how the sample was taken, and why. Why was that particular experiment or sample taken at that time. With that, I will thank you. I will not say the word data, not even one more time, unless you make me in your Q&A. And again, thank you for your time, and feel free to contact us for any advice regarding the data, machine learning, or bioprocess optimization. It's what we do.
Thank you very much for spending this time, and till the next time. Bye.
Thanks, everyone. Thanks for joining.
Bye.